Hello, everybody. My name is Ariane, and I'm working for the German Research Center for Artificial Intelligence in Berlin. I started my PhD in April 2020, and in this talk, I would like to present to you my PhD topic, complex event processing for the Internet of Things. We focus on IoT scenarios with millions of streams and thousands of queries. Those scenarios enable large IoT applications, such as smart cities with several sub-applications. As you can see in the figure, smart streetlights and waste management might contribute to a smart city application. All of these applications and sub-applications are driven by the information provided in form of raw data streams from IoT devices, for example, sensors or smartphones. In order to understand our target scenario a bit better, we have collected some numbers of potential IoT devices for you that may contribute to such a smart city application, or in that specific example, to traffic-related sub-applications in Berlin. So for example, we may use the information provided by over 1 million vehicles and additional 100,000 traffic sensors distributed over the entire city for smart and intelligent traffic flow management. Potential tasks here might be traffic jam prediction and additional rerouting in case traffic jam is actually predicted. Several applications belonging to the smart city have a monitoring character in sense of they want to detect specific information and then add a fast reaction on it. For example, we see traffic jam, so we want to start rerouting immediately. A powerful stream processing method fitting exactly this application character is complex event processing. So complex event processing enables autonomous reaction for these monitoring applications by using user-defined patterns. So let's have a closer look to a smart street light application where the goal is to save energy and provide safety by monitoring a cluster of connected streetlights. So summing up, the action we want to trigger is do we switch on the street light? The information we consider here could be, on the one hand, quite simple, checking light sensors if it's actually dark enough outside that it makes sense to switch on the street light. That is not really smart. We can be a bit more smarter and add the information about is actually anyone in the need of a street lamp. So here we can add the information about is a car close or is a car planning to pass by this street segment, and then only in this case switch on the street light. Going back to the IoT scenario we previously introduced, we haven't yet explained what is the actual problem or what prevents us from having such large IoT applications. So the problem is that the current solution to handle millions of streams and thousands of queries are cloud environments. These cloud environments, as you can see in bullet point 1, have the bottleneck of the need that they have to transmit all the data unprocessed to the cloud, which you can see in point 2, where we can actually start processing the data. In that case, the network is our bottleneck and prevents low latency and real-time processing, especially when we're talking about millions of streams. A solution to overcome this bottleneck, which we show in bullet point 1, is to add an additional fog layer in between the cloud and the IoT devices. So that idea is introduced with the Nebula stream. Here you can see at bullet point 4 that with the fog layer, we have several fog nodes as processing units in the network and can reduce the data close to the sources to the only data required for our queries running in the cloud. And herewith, we can guarantee again low latency and real-time processing. By changing our processing environment, we also need to rethink our current stream processing method. So these ones actually need to leverage this fog layer as much as possible to be able to provide these IoT applications. And that is my PhD topic. In this PhD project, I want to look into 3 subtopics to finally enable complex event processing for the introduced fog and cloud environment. The first step or the first topic I want to look into is large-scale complex event processing engines. So my starting point is to analyze what is the state of the art of complex event processing engines. So what has been done to handle large scale so far, and then identify promising candidates for the combination of in-network processing and cloud complex event processing. The current findings of this step so far are that there's a high variety of different complex event processing engines. So each of the different systems provides a different evaluation mechanism. Some are quite common and traditional use automatas. Others use trees, event processing networks, or also column-based approaches exist. Another very variant feature are the pattern specification language. Here also, many systems provide a different pattern specification language with different expressiveness, and each of these languages is then further optimized for the evaluation mechanism used. To sum up, there's a broad set of different systems with very individual optimizations, and so it's very difficult to use an optimization for yet another system. What we wanted to look into large scale. So what have we learned about large scale, which we can use for the IoT? Unfortunately, we had to learn that most of the CPU solutions are based on centralized architectures and use serial processing models. So that is the bottom part of my diagram, and these solutions are totally outdated for the IoT. If we look a bit further, what has been done for distributed systems, there are still some CPU solutions that have looked into this topic. But for this solution, often optimizations for the cloud are missing. So we allow distribution of the processing task, but we don't provide multi-query optimization, and so we cannot leverage the cloud entirely. If we look for cloud optimized distributed systems, which we want to use for our enabler stream system, we are left with very little approaches, and only one built-in support for complex event processing we were able to find, and that was provided by Apache Flink. Other stream processing engines, for example, Apache Storm or Apache Spark, allow to use complex event processing, but they don't have built-in support. If we look to the second part, what we need for the enabler stream system for our fog cloud environment is in-network processing, and here we look into the situation that there are mainly algorithms which are proposed so far, but we don't really have systems. So here we have a very little set of research we can use for our approach. And when we look into the cloud solutions, which we would use as a fallback for our enabler stream, then we are left with Apache Flink, who has no real competitor, is based on an automata, but we don't know if maybe a tree approach might be better. So here, the question that comes is, do we need to start from scratch again? Do we need to start again to check which of the solution is the best or not? One idea to overcome that problem of complex event processing is that we want to have a look into the similarities between complex event processing engines and stream processing engines. So both of these engines are started their research lines with the same problem of stream processing. Stream processing engines itself, so like Apache Flink, Apache Spark, they have always been optimized for big data and so high-speed query processing, where complex event processing went a bit another direction for event detection and long-term detection of different events. So the task between these engines were different. So now here the idea is, can we bring these both related lines of research together and leverage what we have already done for stream processing engines? So could the future of complex event processing in that case be an extended functionality of stream processing engines? So the idea sounds nice, but there are a lot of open questions if we look more detailed into that vision. So first of all, if we say there is an overlap which we can use, the question is which pattern fall into this overlap and is it sufficient for of the functionalities we want to use for complex event processing. Another question is, if we can use it, that's one issue, but does it make sense performance-wise? So can a stream processing engine outperform an optimized automata version? And on the other side, if we know which pattern fall into the overlap, what do we do with the patterns which don't fall into this overlap? So what do we provide here? Do we add yet another complex event processing engine optimized for just these kind of patterns? What has been done in this direction? So first of all, the equivalence of the different query types, more precisely, that complex event processing patterns can be translated into multi-join queries has been studied and theoretically proved, but not tested performance-wise for large scale. And the next problem is the evaluation and benchmarking of these solutions. So here we don't have well-accepted benchmarks for complex event processing, so there is no real comparison between the solution of Flink, Spark, and Storm we can just use. Concluding our findings of the first point, we had the challenge of the IoT with its volume, its dynamics, and heterogeneity, which leads to the problem that we need to rethink stream processing itself to use our additional fog layer to overcome the problems of the current state of the art. The second problem is the outdated CUP solutions, the centralized architectures and the serial processing model these solutions use that don't really help us to reach large scale for complex event processing. So here, that is an additional problem. And here we start, we finish the current findings for the research topic 1. The next step would be, after identifying the promising candidates, that's the next step we need to do, is to optimize these candidates to leverage the fog layer and potentially also the cloud layer. And here we are adding more IoT properties to the solution. So how do we deal with low-end and mobile devices? So how do we prevent our query result to just leave the network? And additionally, we need to think about the trade-off between latency and transmission costs. And last but not least, we want to provide a pattern specification language for the IoT. So if we go back to cloud solutions, Apache Flink is the only cloud solution we could find with built-in support for complex event processing, but it doesn't offer a pattern specification language yet. So here the user needs to use a programming API, and that's kind of disadvantage mentioned by the CEP community. So what we want to do here is we want to review existing specification language, look more into detail into their properties and features, and evaluate their usability for the IoT. And here also another point is that it might be that we need to add further operators for the IoT. So for example, special operators or maybe specific windows to handle IoT related problems. So herewith I want to end my talk. If you're interested in the Nebula stream and how the challenges are resolved in the system, here is our website and also our Twitter account. So we would be really happy if you follow us. And that's the summary of my talk. And I thank you very much for your attention, and I'm open for any questions.